Okay, we are here to add on another shape. So far, we've talked about parallelograms. That's what this unit so far is going to be about. Now we're adding on a rhombus. So you should have already had all of these properties copied from the parallelogram properties document. That's our key to being successful on this test. I don't expect you guys to memorize all of this. It's a lot. So you need to have it copied down in an easy to access place. You want to have them all organized so you've got kind of one go-to sheet for when we do our test. So adding on a rhombus here, something I want to talk about with this. What makes a rhombus specifically is that all four sides are congruent. That's the definition of a rhombus. If I have four sides exactly and they are congruent, we can call that shape a rhombus. However, and you don't have to copy this part down necessarily, but we're going to kind of keep adding to it. Here's where a rhombus fits in the hierarchy of quadrilaterals. Think about this kind of like a family tree, how you have your grandparents down to your parents and then down to you. And those traits in the family keep getting passed down, right? Your grandparents pass down traits to your parents, who then pass traits down to you. So in the family of quadrilaterals, parallelograms, which we talked about yesterday, are special types of quadrilaterals. A quadrilateral just has to have four sides. So like, that's a quadrilateral if it has four sides, right? A parallelogram specifically has opposite sides parallel, yeah? Now a rhombus is a type of parallelogram that specifically has all four sides congruent. So there's some other types of quadrilaterals and we might talk about those later. Right now we're focusing on just the parallelogram family. So again, something kind of important to realize is that as you go down the family tree, the traits continue to get passed down. Quadrilaterals passes down the trait of having four sides down to parallelograms, and then parallelograms passes down all its traits to rhombus as well, plus some new ones. So let's go ahead and let's look at this. So this is an example of a rhombus. It's just kind of, it can be tilted or it can be straight, but all four sides are the same. That's what makes it a rhombus. So let's look at this. The same process is going to apply. We're going to determine which piece we're looking at here. Remember, we have sides, angles, and diagonals, those three pieces. So let's look. We've got QU is 5, and we're looking for UA. So is this labeled here a side, a piece, or a diagonal? These are sides. So we're going to look back to our properties and see any properties that have to do with sides. Well, we got these two right here, actually. Now, opposite sides being parallel doesn't really help me much because that doesn't tell me anything about their lengths. But this right here definitely does. All four sides are congruent. And so, if this is 5, what does UA have to be as well? 5. If all four sides are the same, all four sides are congruent, they have to be 5 all the way around. So again, that's congruent right there. Same as before. We say, what is this, a side, an angle, or diagonal? Look to the properties and then apply the property to find your answer. Let's try another one. So this one should be obvious. We have the same picture here. It's a rhombus. What are we given? Is this a side, an angle, or a diagonal? Duh, these are angles. Pretty obvious. Let's go ahead and label our picture first, and then we'll go look at our properties. Because, you guys, we have to be so careful. QUA and QUS, those are different angles. We have to be careful how they are labeled. Follow with your pencil. Q to U to A. That means that's this angle. It's the middle letter, right? Now, this entire thing is 36 degrees. What I am trying to find is, let me go ahead and get a different color here. QUS. So I'm going to follow again, Q to U to S. So I just want this piece. I know the whole thing is 36 and I'm just trying to find that piece. Let's go ahead and let's look back to our properties and see all of our angles. So we've got a lot of options here actually. We've got angles here, angles here. I'm going to keep recording and I'm just going to have to change this, I think, because I don't want to stop recording again. Really? Do I not have the Is that only true in a square? I thought it was true in a rhombus. The diagonals bisect opposite angles. Oh, I missed that one. Opposite sides congruent. 1, 2, 3, 4, 5, 6, 7. What did I mess up on? Four congruent sides. Consecutive angles are supplementary. Opposite angles are congruent. All four sides are congruent. Oh, I think that's what that was supposed to be. No, both pairs of opposite sides parallel. Opposite sides are parallel. Diagonals bisect each other. I should have 4 diagonals, right? Diagonals bisect each other. Diagonals bisect. Oh, they are not congruent. Shoot. Okay. Okay, let's come back to this. Okay, so let's look back to our properties. We're finding any that are talking about angles. I've got a few here. I've got these two, but be careful. I also have, even though this one talks about diagonals, it does also talk about angles. So we got to be careful with this one. We have 1, 2, 3 properties about the angles. Now looking at the first two, this says opposite angles and consecutive angles. What that means is specifically different angles. Now, these are different angles, but these are opposite, like angle Q and angle A, versus angle Q and angle D are consecutive. We're talking about kind of looking at just angle U. We're looking at all of angle U and then a part of angle U. So if we notice, this one right here says the diagonals bisect opposite angles. Here's what that means then. These angles here, opposite across from each other, are going to be cut in half. So this is half and this is half. This is half and this is half. So what I'm actually looking for here, measure of angle QUS, if the entire thing is 36, QUS is half of that. So what's half of 36? 18. Because the angles are also bisected by the diagonals. If the angles are cut in half and I was given the whole thing is 36, half of it was 18. Good, let's try one last one. So we gotta see what's being labeled here. QA is 10 and we are looking for DU. So, dang it. Okay, let's look at this last one. So this one is kind of a tricky one. Now, obviously we can see that we are trying to find QSU. Now let's look at this one here real quick. QSU. That's this angle. That's an angle, but it's made up of diagonals, right? QS and SU are parts of diagonals. So this is a little bit different than the other ones we've had to deal with when we've had angles. Let's go ahead and let's look at our properties and see what we can find. So, clear a different page. I've got stuff about opposite angles, consecutive angles, but those are talking about the corners of the rhombus. What we're looking at here is an angle made by the diagonals. Now, this last one actually tells us the angle that is made by the diagonals. If the diagonals are perpendicular, that tells us the degrees, because perpendicular means crosses at a right angle. So this is actually a right angle right here. And how many degrees are in a right angle? 90 degrees. So angle QSU actually equals 90 degrees right there. So all of these, if the diagonals are perpendicular, all of those angles actually equal 90. So we're going to try some harder ones with this, but again, it's going to be the same process as it was yesterday. Pick the piece, determine the property we're going to use, and then set up your equation to solve is what we're going to be doing when it gets a little bit harder.